Welcome to this engineering analysis of the 66 RFE and 68 RFE transmissions. These transmissions are used in various Chrysler, Dodge, Jeep, and Ram vehicles. The valve body, located at the bottom of the transmission, is one of the primary areas where engineering issues occur. These transmissions are found in several vehicle models, including Dodge Ram 2500 and 3500 trucks from 2007 onwards, commercial 4500 and 5500 models, and certain Jeep Grand Cherokee diesel variants. While robust in some aspects, these transmissions have several engineering flaws that owners should be aware of. Throughout this series, we'll focus particularly on the P0871 code that often leads to unnecessary and expensive transmission rebuilds. The 66 RFE and 68 RFE transmissions represent a significant evolution in Chrysler's automatic transmission lineup. Introduced in 2007, these transmissions evolved from the earlier 5 and 45 RFE, which itself was an upgrade of the 45 RFE first launched in 1998. The 66 RFE and 68 RFE are 6-speed automatic transmissions that share a common architecture but are optimized for different applications. The 66 RFE is primarily found in Ram 1500 series trucks, equipped with the 5.7-liter HEMI V8 engine. It's designed for lighter-duty applications while still providing reliable performance for half-ton trucks. The 68 RFE is the heavier-duty variant, designed specifically for the Ram 2500 and 3500 series trucks, paired with the 6.7-liter Cummins turbo diesel engine. It features reinforced components to handle the increased torque output. Despite their different applications, these transmissions share many common components and, unfortunately, common failure points. Both transmissions exhibit similar vulnerabilities in their valve bodies, solenoid packs, cooling systems, and wiring harnesses. These shared weaknesses stem from their common design architecture. While the 68 RFE features strengthened components to handle diesel torque, both transmissions suffer from similar design limitations that can lead to premature failure if not properly addressed. The valve body is a critical component in the 66 RFE and 68 RFE transmissions, serving as the hydraulic control center. Let's examine its basic structure. The valve body is primarily made of aluminum and contains numerous precisely machined valve bores. The first fundamental design flaw is the aluminum material used for the valve body. Aluminum is susceptible to warping under the extreme heat generated during transmission operation. The second critical design flaw involves valve bore wear. These precision machine channels require extremely tight tolerances for proper operation. As the aluminum valve body wears against the harder steel valves, the bores become irregularly shaped. This creates uneven clearances and compromises hydraulic precision. The third major design flaw is internal leakage. As the valve bores wear, transmission fluid begins to bypass the critical control valves. This leakage has direct consequences on transmission performance. Hydraulic pressure, which controls shift timing and feel, becomes inconsistent. These valve body issues manifest as several noticeable performance problems that Dodge, Ram, and Jeep owners frequently report. In summary, the valve body design represents one of the most fundamental weaknesses in the 66 RFE and 68 RFE transmissions. These engineering flaws create a cascade of hydraulic control problems that progressively worsen over time. The pressure control solenoids in the 66 RFE and 68 RFE transmissions represent a significant engineering weakness. These transmissions contain multiple pressure solenoids that control hydraulic pressure for clutch engagement. The solenoids regulate precise pressure to each clutch pack, enabling proper gear shifts and torque transfer. Let's examine the internal structure of a pressure solenoid to understand its vulnerabilities. The solenoids suffer from two primary failure points. First, the electrical coil can fail due to excessive heat exposure. Second, the valve itself experiences premature wear from continuous pressure cycling, especially in heavy-duty applications. When pressure solenoids begin to fail, they cause multiple drivability issues. The overdrive pressure solenoid is particularly problematic in these transmissions. These solenoids are fundamentally under-designed for their operating conditions, especially in trucks used for towing or heavy-duty applications. The overdrive pressure solenoid requires special attention as its failure is often the first indication of transmission problems and can lead to complete transmission failure if not addressed. The 66 RFE and 68 RFE transmissions suffer from a fundamentally undersized cooling system that contributes to premature transmission failure. Let's examine the basic cooling system design. Transmission fluid circulates between the transmission and the cooling radiator through these lines. Hot fluid leaves the transmission through the lower line, gets cooled in the radiator, and returns to the transmission through the upper line. Temperature gauges show normal operating conditions versus heavy towing conditions. During heavy towing, temperatures can exceed 240 degrees Fahrenheit. While the 66 RFE may operate within acceptable temperature ranges during normal driving, the 68 RFE, which handles much higher torque loads, uses the same undersized cooling system. This engineering oversight creates a critical problem for heavy-duty applications. The cooling capacity remains the same, but the heat generation is significantly higher. High fluid temperatures accelerate wear on critical transmission components. Let's examine how excessive heat damages these parts. Rubber seals harden and crack when exposed to high temperatures, leading to fluid leaks and pressure loss. Clutch friction material deteriorates more rapidly, causing slippage and eventual transmission failure. Solenoids experience increased electrical resistance and eventual failure as their components degrade under heat stress. The valve body can warp under extreme heat, causing valves to stick and malfunction, leading to erratic shifting and pressure control issues. This inadequate cooling system design is a fundamental flaw that must be addressed through engineering solutions. A larger transmission cooling radiator increases surface area for better heat dissipation, helping maintain safe operating temperatures. Installing an auxiliary cooler provides supplemental cooling capacity, particularly important for towing and heavy load applications. A higher flow pump increases fluid circulation through the cooling system, removing heat more efficiently from the transmission. Without addressing the cooling system inadequacies, these transmissions will continue to experience premature failure, particularly in heavy-duty applications. The P0871 code refers to a transmission fluid pressure switch C-circuit performance or rationality issue. This pressure switch is responsible for monitoring the hydraulic pressure in the overdrive circuit of the transmission. The pressure switch C is located in the valve body and sends voltage signals to the powertrain control module or PCM. During normal operation, the switch sends an expected voltage pattern to the PCM. When the PCM detects an unexpected voltage pattern from this switch, it triggers the P0871 code. It's important to understand that this code doesn't necessarily indicate catastrophic transmission failure, despite what many repair shops might tell you. The issue could be related to wiring problems, solenoid degradation, or valve body wear, all of which can often be repaired without a complete transmission rebuild. The overdrive pressure switch is a critical component in the 66 RFE and 68 RFE transmissions that monitors hydraulic pressure in the overdrive circuit. Located in the valve body, this switch is designed to close when adequate hydraulic pressure, typically between 70 and 90 psi, is present in the overdrive circuit. When the transmission shifts into overdrive, hydraulic pressure increases in the circuit. Once pressure reaches the threshold, the switch contacts close, completing an electrical circuit. This closed switch sends a voltage signal to the powertrain control module, confirming that proper hydraulic pressure exists for overdrive operation. The PCM continuously monitors this signal and compares it with other sensor inputs, such as gear selector position, vehicle speed, and engine load. If the PCM detects that the switch signal is inconsistent with what it expects based on these other inputs, it will trigger the P0871 diagnostic trouble code. Understanding this mechanism is crucial for proper diagnosis of transmission issues. The pressure switch provides direct feedback about the hydraulic system's performance, which can help distinguish between electrical and mechanical problems. The overdrive pressure switch serves as both a confirmation of proper hydraulic pressure and a safety mechanism to prevent overdrive engagement under improper conditions, protecting the transmission from potential damage. When transmission shops encounter the P0871 code, many immediately jump to recommending a complete transmission rebuild. This misdiagnosis leads to unnecessary expenses between $3,000 and $5,000, when a targeted repair often costs far less. The P0871 code actually indicates issues with specific components, not necessarily internal transmission damage, requiring a complete rebuild. The code often indicates issues with the pressure switch itself, the wiring harness, worn valve body components, or solenoid problems. A proper diagnostic approach should first test these specific components before concluding that a full rebuild is necessary. By following this targeted diagnostic process, you can avoid unnecessary transmission rebuilds and save thousands of dollars. The internal wiring harness in 66 RFE and 68 RFE transmissions is a common source of P871 code issues. This wiring harness connects critical components, including the pressure switches and solenoid pack, to the transmission control module. These harnesses experience two primary failure modes that lead to the P0871 code. Connector corrosion affects the terminal contacts, while wire insulation breakdown exposes conductors to potential shorts. These failures are accelerated by harsh environmental conditions inside the transmission. High operating temperatures of 180 to 200 degrees Fahrenheit weaken plastic connectors and cause wire insulation to become brittle over time. Continuous exposure to transmission fluid, especially degraded fluid, further accelerates the breakdown of electrical components. These wiring issues create intermittent electrical connections that confuse the transmission control module. When the connection is compromised, the PCM receives erratic voltage signals from the pressure switch. This triggers the P0871 code, even though there's no actual mechanical failure in the pressure switch or hydraulic system. Here are some key identification tips to determine if your P0871 code is caused by wiring harness issues rather than mechanical problems. If the code appears intermittently, especially after the transmission reaches operating temperature and clears itself without intervention, wiring issues are likely the culprit. The valve bodies in 66 RFE and 68 RFE transmissions develop specific wear patterns that can trigger trouble codes without requiring a complete rebuild. The valve body contains critical components, including the pressure regulator and overdrive circuit bores. In normal operation, these bores maintain precise hydraulic pressure to control the transmission's operation. Over time, these transmissions develop specific wear patterns in critical areas of the valve body. The metal-to-metal contact causes erosion of the bore surfaces. As these bores wear, they create gaps where hydraulic pressure can bleed off. This is particularly problematic in the overdrive circuit, where precise pressure is essential. This pressure loss is detected by the overdrive pressure switch, which monitors hydraulic pressure in the circuit. When pressure falls below the threshold, the switch signals incorrectly, triggering the P0871 code. The good news is that this issue can often be addressed without a complete transmission rebuild. Reconditioning or replacing just the valve body restores proper hydraulic pressure to the system. Transmax Transmissions in Ocala, Florida, has developed a specialized diagnostic protocol for the P0871 code that differs significantly from standard approaches. Unlike many shops that simply read the code and replace parts, Transmax begins with pressure testing to verify actual hydraulic pressures in each circuit. This crucial first step determines whether the issue is mechanical or electrical in nature, preventing unnecessary parts replacement. The second step in their protocol uses specialized electrical testing equipment to check the integrity of the wiring harness. This detects issues like shorts, opens, or intermittent connections that standard diagnostics might miss. Third, they conduct comprehensive testing of the solenoid pack, measuring resistance values and response times. Finally, they analyze all test results to determine the exact root cause of the P0871 code before making targeted repair recommendations. Let's compare the standard diagnostic approach with Transmax's comprehensive protocol. The standard approach typically just reads the code and replaces parts without verifying pressures, leading to a high risk of misdiagnosis. In contrast, Transmax's approach includes comprehensive testing, circuit verification, and specialized equipment to identify the exact cause of the P0871 code. This methodical diagnostic protocol allows Transmax to make targeted repair recommendations, saving customers time and money by addressing the actual root cause. By following this specialized diagnostic protocol, Transmax ensures that repairs are done right the first time, avoiding the common cycle of repeated transmission issues. Transmax's innovative approach addresses transmission problems through specialized valve body reconditioning rather than complete transmission replacement. The valve body is a critical component in the 66 RFE and 68 RFE transmissions, acting as the hydraulic control center. Transmax's reconditioning process includes several precision steps to restore optimal functionality. First, technicians carefully remove the valve body from the transmission. Next, they methodically disassemble all components for thorough inspection. Each component is carefully inspected for wear patterns, scoring, and damage. The valve body plates are precision resurfaced to eliminate warping and ensure proper sealing. Worn valves and springs are replaced with new components to restore proper hydraulic function. Transmax upgrades to more durable components, specifically designed to address the weaknesses in the original equipment. Finally, the valve body is reassembled and calibrated to ensure optimal pressure and timing. This reconditioning process offers several significant benefits over a complete transmission rebuild. One of the most compelling advantages is cost savings. Valve body reconditioning typically costs between $800 and $1,200 compared to $3,000 to $4,500 for a complete rebuild. By addressing the root causes of P0871 codes and other valve body-related issues, Transmax's reconditioning solution provides a cost-effective alternative that often delivers better performance than the original equipment. Transmax has identified aftermarket solenoids that significantly outperform OEM specifications in the 66 RFE and 68 RFE transmissions. These upgraded solenoids feature improved electrical characteristics, including tighter resistance tolerances, faster response times, and more precise pressure control capabilities. By replacing just the problematic solenoids rather than the entire transmission, Transmax can resolve the notorious P0871 codes while improving overall transmission performance. This targeted approach delivers significant cost savings to customers. While a full transmission replacement can cost between $3,500 and $5,000, the upgraded solenoid solution costs just $500 to $800. Transmax's upgraded solenoid technology provides a precise, targeted solution that resolves transmission issues at a fraction of the cost of replacement. In 66 RFE and 68 RFE transmissions, the internal wiring harness is a common source of electrical problems. This wiring harness connects critical components, including the solenoid pack and pressure switches that monitor transmission function. Two primary failure points affect these harnesses: connector corrosion and wire damage. Corroded connectors develop green or white residue that interrupts electrical contact, while damaged wires with worn insulation create intermittent short circuits. Transmax has developed specialized repair techniques that address these issues without requiring complete transmission replacement. First, technicians use custom tools to access connectors with minimal disassembly, preserving surrounding components. Next, connectors undergo a restoration process using specialized cleaning solutions that remove corrosion and restore conductivity. Damaged wires are repaired using precision splicing techniques and wrapped with high-temperature insulation that withstands transmission fluid exposure. Finally, protective measures are applied, including dielectric grease and enhanced routing, to prevent future issues. This repair approach offers significant advantages over complete transmission replacement, including dramatic cost and time savings. These repair techniques directly address the intermittent electrical issues that trigger the P0871 code. The P0871 code indicates intermittent problems in the overdrive pressure switch circuit. Before repair, the electrical signal fluctuates erratically. After repairing the wiring harness, the signal stabilizes, resolving the intermittent electrical issues without requiring extensive disassembly. The overdrive pressure switch in the 66 RFE and 68 RFE transmissions is often the root cause of the P0871 code. Transmax has found that in many cases, replacing just the pressure switch itself resolves the issue without needing more extensive repairs. Their pressure switch replacement procedure follows 5 key steps. First, locating the switch on the valve body, then disconnecting the wiring harness and removing the faulty switch. Finally, installing the new Transmax switch and reconnecting the wiring. After replacement, proper calibration is essential. A faulty switch typically shows low pressure readings, while the new switch restores normal operation. The cost difference is substantial. A pressure switch replacement typically costs around $250 compared to $3,500 or more for a full transmission rebuild. This simple solution offers quick turnaround, typically same-day service, and includes full system diagnostics to verify the fix. Transmax pressure switches are designed for improved durability over the original parts. The accumulator system is a critical component in the 66 RFE and 68 RFE transmissions, responsible for cushioning shift engagement. It consists of pistons and springs that absorb hydraulic pressure spikes, providing smoother gear transitions and reducing overall wear on the transmission. During normal operation, hydraulic pressure pushes against the piston, which compresses the spring. When pressure drops, the spring pushes the piston back, creating a dampening effect during shifts. Over time, these accumulator components develop critical weaknesses. Springs lose tension, pistons develop wear patterns, and seals deteriorate, causing hydraulic fluid leakage. These deteriorating components directly affect shift quality, causing harsh or delayed shifts and inaccurate pressure readings that can trigger the P0871 code. Transmax has developed a specialized kit to address these accumulator weaknesses. The kit includes upgraded springs with improved materials, precision-machined pistons, and enhanced sealing technology. Most importantly, this solution can be installed without a complete transmission disassembly, providing a cost-effective fix for another potential cause of the P0871 code. Torque converter lockup issues are frequently misdiagnosed in 66 RFE and 68 RFE transmissions. The torque converter contains a lockup clutch that directly connects the engine to the transmission when engaged. This lockup clutch is controlled by a complex hydraulic circuit that interacts with the overdrive circuit. Several problems can occur with the torque converter lockup system. The clutch material can deteriorate over time, leading to erratic engagement or slipping under load. A critical point often missed in diagnosis is how the torque converter lockup circuit interacts with the overdrive circuit. Problems in the lockup system can directly trigger P0871 codes, which indicate overdrive pressure switch issues. Transmax approaches these issues through comprehensive diagnostic techniques rather than immediately recommending costly converter or transmission replacement. Most lockup clutch performance issues can be resolved by reconditioning the controlling solenoids and pressure circuits, rather than replacing the entire converter or transmission. By addressing the root causes in the control system, Transmax saves customers thousands of dollars while providing a repair that resolves the actual problem. The Powertrain Control Module, or PCM, manages both engine and transmission functions in Dodge Ram trucks. It constantly communicates with the 66 RFE or 68 RFE transmission, sending control signals and receiving sensor feedback. In many cases, the P0871 code, indicating an overdrive pressure switch rationality problem, is triggered by outdated PCM calibrations rather than actual mechanical failures. Chrysler has released several calibration updates over the years to address known issues with transmission control logic. Transmax Transmissions includes PCM calibration verification and updates as a standard part of their diagnostic process. In many cases, simply updating the PCM calibration resolves the P0871 code without any mechanical repairs needed, saving customers significant time and expense. Transmax has developed a comprehensive preventative maintenance schedule for 66 RFE and 68 RFE transmissions. The factory-recommended fluid change interval of 100,000 miles is insufficient for these transmissions. Transmax recommends changing the transmission fluid every 30,000 miles, which is significantly more frequent than the manufacturer's guidelines. Installation of an auxiliary cooler is essential for these transmissions, which are prone to overheating. The additional cooling capacity can lower operating temperatures by 30 to 50 degrees Fahrenheit, significantly reducing wear on internal components. Periodic pressure testing is crucial for early detection of issues before they cause catastrophic failures. Normal line pressure should be between 65 and 75 psi. Readings below 60 psi indicate potential problems that require immediate attention. Following Transmax's recommended maintenance schedule provides comprehensive protection for your transmission. The schedule includes initial fluid analysis at 15,000 miles, followed by regular fluid changes, pressure tests, and a comprehensive service at 90,000 miles. Following these preventative maintenance recommendations provides significant benefits. These include preventing P0871 codes, reducing operating temperatures, extending transmission life, saving thousands in repair costs, and maintaining optimal shift quality. By implementing these preventative maintenance recommendations, you can significantly improve the reliability and longevity of your 66 RFE or 68 RFE transmission. Let's examine a real-world case study of Transmax's repair approach. A 2014 Ram 2500 with the 68 RFE transmission came to Transmax after experiencing shifting problems and triggering a P0871 diagnostic code. Before contacting Transmax, the owner received a quote from another repair shop for a complete transmission rebuild. Let's look at the cost comparison. The original quote of $4,200 was based on the traditional approach of completely rebuilding the transmission. This is often unnecessary for P0871 codes. Transmax took a more targeted approach. Their technicians diagnosed the specific issues, a worn valve body and a faulty overdrive solenoid. Instead of a complete rebuild, Transmax performed precision repairs, addressing only the actual problems. Their total cost was $1,450, saving the customer over $2,700. The real proof of Transmax's approach is in the long-term results. This truck has now run for 50,000 additional miles without any transmission issues. This case demonstrates how understanding the specific failure points in the 68 RFE transmission allows for more economical and equally effective repairs compared to complete rebuilds. Beyond just fixing immediate issues, Transmax implements key engineering improvements during their repairs. Let's examine the 3 critical improvements that address fundamental design flaws in the 66 and 68 RFE transmissions. First, Transmax installs improved valve body check balls. These precision machined steel balls replace the factory plastic components. Second, they upgrade to higher quality sealing rings. These metal-reinforced composite rings replace the standard Teflon rings. Third, they modify the pressure regulation system with recalibrated control valves and enhanced accumulator spring rates. These engineering improvements address the fundamental design flaws of the original transmission. The result is a transmission that's often more reliable than when it was new, with 300% longer service life and smoother shifting, even under high load conditions. While many P0871 codes can be resolved without a complete transmission rebuild, there are cases where more extensive work is actually necessary. Transmax Transmissions provides honest diagnostic assessments based on thorough examination of your transmission's condition. Several key indicators tell us when a rebuild is truly needed, rather than just a component repair. One clear sign that a rebuild is necessary is finding clutch material or metal shavings in the transmission pan during inspection. Internal damage to components like clutch packs is another indicator that requires more than just a simple repair. Instead of temporary fixes that might leave underlying problems unaddressed, Transmax focuses on providing the most cost-effective long-term solution. Transmax provides honest assessments based on their diagnostic findings, recommending rebuilds only when truly necessary for the long-term reliability of your transmission. Their goal is to provide the most cost-effective solution that addresses the actual problem, not just the symptoms. In conclusion, the 66 RFE and 68 RFE transmissions have several engineering flaws, but these issues don't always require a complete rebuild. The P0871 code is frequently misdiagnosed as a catastrophic failure, when specialized diagnostics can often identify the root causes. A traditional transmission rebuild can cost between $3,500 and $5,000. Transmax's specialized solutions typically range from $1,200 to $2,000. The Transmax advantage comes from their specialized knowledge of these transmissions, offering precision diagnostics of valve body and solenoid issues and targeted repairs instead of complete overhauls. Their technical expertise with these specific transmission models allows them to provide long-term reliability improvements, backed by comprehensive warranties. By choosing Transmax Transmissions in Ocala, Florida, vehicle owners can save thousands of dollars while achieving superior reliability for their Dodge, Ram, or Jeep vehicles equipped with these transmissions.